Welcome to Beta Online Learning, and this is the video for 9th Standard CBSE Mathematics on the topic Surface Areas and Volumes. In this video, we shall see all you need to know about spheres and hemispheres, the essentials of spheres and hemispheres. Let's see the definition of a sphere. A sphere is a three-dimensional figure, which is a solid figure which is made up of all points in the space which lie at a constant distance called the radius from a fixed point called the center of the sphere. A hemisphere is half of a sphere. When a sphere is cut into two equal parts, then each part is called a hemisphere. A sphere is made up of two hemispheres. These are some of the formulas to remember. First, we shall see the surface area of a sphere. A sphere has a curved surface area and it's also the total surface area. So it's a closed surface, so it will have the surface area of a sphere is equal to 4 pi r squared, where r is the radius of the sphere. Hemisphere has curved surface area as well as total surface area, because hemisphere has a curved surface and a straight surface at the bottom or at the top. It's a circular base. Actually, it has a circular surface also. And it is curved surface area of a hemisphere is equal to 2 pi r squared. And the total surface area of a hemisphere is 3 pi r squared. Let us see the volume of a sphere is given by 4 by 3 pi r cubed. The volume of a sphere, volume of a hemisphere is equal to 2 by 3 pi r cubed, which is half the volume of a sphere. In all the above formulas, r denotes the radius of the sphere or hemisphere. Next, we shall see hollow spheres and hemispheres. Hollow sphere is a sphere which is empty inside. It has empty space inside. It may be filled with a gas or a liquid. A hollow sphere is a closed surface. However, the material in which the sphere is made may be a metal or any solid which has a definite thickness. It has an inner surface and an outer surface. Hence, there will be two radii, the inner radius and the outer radius. The inner radius is denoted by small letter r, and the outer radius is denoted by capital letter R. The thickness of the hollow sphere is given by the letter T. Small letter t is equal to capital R minus small r. Capital R minus small r. If the inner radius and the thickness are given, then the outer radius can be found by R. Capital R is equal to small r plus t, the thickness. You have to add the thickness to the inner radius to get the outer radius. Examples of hollow spheres are ball, balloons, spherical shells. Volume of the matter contained inside a hollow sphere is given by the same formula as the volume of a sphere, that is equal to 4 by 3 pi r cubed. The volume of air inside a hollow sphere can be found using this formula. Volume of air or volume of water, liquid inside this hollow sphere can be found using this formula. V is equal to 4 by 3 pi r cubed. But the volume of the material or the metal used to make this hollow sphere is given by V is equal to 4 by 3 pi into, within brackets, we have capital R cubed minus small r cubed. Hollow hemispheres. A hollow hemisphere is half of the hollow sphere. Hollow hemisphere, a hemispherical bowl which is used to hold water is an example of a hollow hemisphere. In fact, a hollow hemisphere we can use for as a vessel, as a bowl for serving soup and other. Even a cup is in the form of a hollow hemisphere. A dome is another example of a hollow hemisphere. It has only curved surface area, CSA, because the bottom surface is not present. So the total surface area is not considered here, only the curved surface area, the CSA, is considered. The volume of liquid contained in a hollow hemisphere is the same as the V is equal to 2 by 3 pi r cubed. But the volume of the material with which the hollow hemisphere is made is given by V is equal to 2 by 3 pi into capital R cubed minus small r cubed. These are the formulas required for, and as we know that if the thickness is given, if the thickness is known, and the smaller radius, that is the inner radius of the hemisphere or a sphere is given, we can find the outer radius, capital R is equal to small r plus t, the thickness. Here is a question given in the textbook, NCERT textbook of 9th standard CBSE Mathematics. Here the problem is this: 27 solid iron spheres, each of radius small r and surface area capital S, are melted to form a sphere with surface area S dash. Find the first part of the question, subdivision 1, radius r dash of the new sphere, which is the bigger sphere. Second subdivision, subdivision 2, the ratio of S to S dash. Let us see the solution. First part of the question, surface area of each small sphere is given by is equal to 4 pi r squared, small r squared. It is given in the question that small r is the radius of the small sphere. Now 27 such small spheres are melted to form a big sphere of radius r dash. To find the radius of the new sphere, which is a larger sphere, a big sphere, we have to equate the volume of 27 small spheres to the volume of the new big sphere. New big sphere is the one which is formed by melting these 27 small spheres to form the new big sphere. We have this equation. This equation is 4 by 3 pi r dash cubed is equal to 27 into 27 times 4 by 3 pi r cubed. The 4 by 3 and 4 by 3 pi, 4 by 3 pi and 4 by 3 pi gets cancelled on both sides of the equation. We are left with r dash cubed is equal to 27 r cubed. Of course, 27 in here is actually 4 by 3, 27 it should be 9r the whole here. R dash cubed should be equal to 3r the whole cubed. It is not 9r, it is 3r the whole cubed. It should be 3r the whole, because 27r cubed you will get. It should be 3r the whole cubed. It is 3r taken as whole cubed. So when we take 3r the whole cubed, it will be, when taking cube roots, you will get r dash is equal to 3r. You will get the answer as r dash equal to 3r, which is nothing but the radius of the largest sphere is 3 times the radius of the small sphere. To find the ratio of S to S dash, the surface areas of the two spheres, S is equal to 4 pi r squared, S dash is equal to 4 pi r dash squared, which is nothing but 4 pi into 3r the whole squared, which is 9 times 4 pi r squared. You get 36 pi r squared, which is 9 times the 4 pi r squared. So 9s, since r dash is equal to 3r. So the ratio will be S to S dash will be equal to S is to 9s, which is equal to 1 is to 9. And that's the answer for this question. We are going to see a hard challenge problem, which is the HOTS interdisciplinary question. A surface area of a sphere, which is given by A, capital letter A, is directly proportional to the square of its diameter. If the surface area is doubled, what will be the change in its diameter to affect this change in surface area? Express this as a percentage is the second part of the question. The formula of the surface area of a sphere is given in terms of its diameter. A is equal to pi d squared, where d is the diameter of the sphere. We are using this formula here. This formula is given in the question itself. The surface area of a sphere is given in terms of its diameter. So it becomes not 4 pi r squared, but it is pi d squared. Let us now go into the solution to this problem. There are two parts in this question. First, we have to find the change in the diameter to make the surface area of the sphere double. Next, we have to express this change in diameter as a percentage. Let us see this one by one. The first part of the question here, we are A is equal to pi d squared as equation number 1. It is given that A becomes 2A. Let us take the condition given in the question itself. A is doubled. If surface area is doubled, it will become 2A. So multiplying the first equation by 2. So you get 2A left hand side, 2A, multiplying both sides of the equation 1 by 2 on both sides, we get 2A is equal to 2 pi d squared. So 2A will be equal to pi into, we write this 2d squared, pi separate, pi is a constant which does not undergo any change. Remember, pi is a constant. So we do not make any change in this value. We should only make changes in the diameter. We have been asked to find out how much the diameter changes, so that the surface area of the sphere becomes double, 2A. So we can write this as root 2d the whole squared. 2d squared becomes, we should simply take the square root and then square it. So root 2d the whole squared, this is equation number 2. Now comparing the first and the second equation, we are left with, from 1 and 2, we see that there is a change in the diameter. See, pi d squared, for 2A it becomes root 2d. So the change in the diameter is root 2 times square root of 2 times d, the diameter. So the diameter changes from d to root 2d. Hence the change in the diameter, this is the first part of the question. The change in the diameter is now going to be root 2d minus d, the difference. Taking d outside, we get d into square root of 2 minus 1 within brackets. We know that square root of 2 is root 2 is how much? 1.414 minus 1, 0.414 d. That is the change in the diameter expressed as a decimal fraction. Now we'll go to the second part of the question, expressing this change as a percentage. Change in the diameter by the original diameter into 100, because it's a percentage. We have to multiply by 100. That is equal to d into this. This is the change. D into root 2 minus 1. This is the change in diameter divided by the original diameter is d itself. So we can cancel out d. We'll get root 2 minus 1 into 100. Root 2 minus 1 is 0.414 into 100, which is 41.4%. And that's the required answer. Hope you understood this. Thanks for watching this video. And this is all you need to know about spheres and hemispheres. You have the formula. That's what we have seen. Let's go back to the this one. We have seen what are the things we have seen. We have seen spheres. We have seen hemispheres, definition of a sphere. And we saw the formulas to remember surface area of sphere, CSA of hemisphere, total surface area of hemisphere, volume of sphere, and a volume of hemisphere. We also saw hollow spheres and hemispheres. Using hollow spheres and hemispheres, we can find out the volume of the material or the metal used to make the hollow sphere. Hence, this is all you need to know about spheres and hemispheres, and the exercise questions can now be solved from the NCERT textbook. You can now solve the exercise questions. Thank you.